All right, welcome to Software, and we will be looking at the topic arithmetic progression. We want to know and understand what it is first of all, and then in subsequent videos, we will get to solve a lot of exercises, and by so doing, understand it better. So, first of all, I'll start with what is an arithmetic progression. So, an arithmetic progression is a sequence of numbers where the difference between them or between two consecutive numbers or terms is the same. So a typical example of a sequence is, for instance, if I have 2, 5, yes, it's and let me say 11 here. So in arithmetic progression and in sequence generally, we call this the first term, and the first term, just like it is here, is A. So A is referred to as the first term, and we usually say that an arithmetic progression carries the form of this, which is stated here. And as we proceed, you get to understand why we say that. So back to the sequence, and then if you look at the next one, we have common difference. And if you recall, when I explained the meaning of arithmetic progression, I said they are sequence of number where the difference between consecutive number is the same. So which means that if I'm to get my common difference, this is the first term, which is A. This is what we call the second term, which is 5. So if I want to get my common difference, I would say the second term, which I can write as T2 minus the first term, which I can write as T1. And then if I do a normal subtraction, of course, I would have 5 minus 2, and 5 minus 2 should give me what? It should give me 3. So this should give me 3. So I can also use another number in the sequence. Let me use the third term in this case. If I use the third term, I will have T3, and then I'll minus the second term, T2. I should still have the same number because that's the definition of arithmetic progression. So, and if I do that, I'll have 8 minus 5. And 8 minus 5 should also give me 3. So this means that yes, this sequence is an arithmetic progression because it's adding up by the same value, which we call the common difference. That's what we call the common difference, and you can see it there. Now, in some cases, there are some cases where you would have a negative sequence, that you would have is d to be a negative value, and in that case you would see that the series take a different shape because instead of adding up it will be decreasing. A typical example is if I have a series like this. If I have 20 and I have 15 and I have 10, now you would see that though there is a one difference, but in this case it is signifying a decrease, because if we are to do this, we would have that our second term take away 20, which will give us negative 5. So in this case, we have 15 minus 20, which would give us negative 5. And you see that in that case, you'll be noticing a decrease in the sequence. So that's what arithmetic progression is all about. A sequence where the difference between two consecutive terms or numbers, which but in a sequence we call it terms, is the same. So, and then if in a sequence you now have the arithmetic difference to be 0, it means that in that case we would have something like this, which is rare. If we have a sequence like this, 7, 7, 7, and let me just give dot, dot, dot. So now if I have this sequence, you would see that the common difference between the second term and the first term is 0. So that tells you that if your d is 0, it means that every term in the sequence would be the same. So that's for a case where the common difference is 0. So that's for that. And then if you look at the next thing that was identified as the nth term formula. The nth term formula is a formula we use to find a term. Now, instead of listing out all the sequence, we can use our nth term to get the term. So, and if you look at the formula, it says A here, which stands for the first term, plus into brackets n minus 1. N would be the term, the number, that is the term you are looking for. If, for instance, we are looking for the eighth term, so all we need to do here is put it here, get the, we already have the first term, and then we get our common difference, and we should be good to go. So that's how we do that. So let's find out what would be the eighth term of this sequence. So we'll do that by simply applying our formula. So let's do that quickly. So I have this to be, remember our formula says that a from here is 2. So our a from here is 2, and then plus the bracket says n. And I said let's look for the eighth term. So this means we have 8 minus 1, and then our common difference. Our common difference is what we got here to be 3. So we have this to be 3. So which means we would have 3 here. And then you see that if we go ahead to do this, we'll have this to be, we'll have 2, and then inside the bracket we'll have 8 minus 1, and 8 minus 1 should give us 7. 8 minus 1 should give us 7, and then we'll multiply by 3. Multiply by 3 would have what? Would have 21, because 7 times 3 is 21, and which means that our final answer here for to get the eighth term should be 23. So 23 is our nth term. So in subsequent videos, we'll also look at solving more questions on the nth term, and also we also have the sum of nth term. We'll look at different questions and we'll understand what it means. So that'll be all for today. I'll see you in the next video.